Today your notes are brought to you by Halloween. Happy Halloween. And look at that adorable baby. Happy Halloween. Today your notes are 4-7, medians, altitudes, and perpendicular bisectors. Today you're going to be creating a table on your top section. Halfway down, about halfway down, you'll write the title, The Almighty Perpendicular Bisector. You have a glue-in that I hope you grabbed. And the last 5 lines at the bottom I'd like you to reserve for the What Am I game. Okay, let's get started. At the top of your notes, I'd like you to write the title, What Am I? And you're going to use these reference notes in the game's What Am I game at the very bottom of your notes. The first thing I'd like you to do is create this table. It has 3 rows, 2 columns, with the titles Median, Altitude, and Perpendicular Bisector. What we're going to do is go over each of those terms, and you're going to fill in some missing words here. The median of a triangle connects the top vertex to the opposite side right at the midpoint. Now that could mean that it looks straight up and down, but it also could be kind of slanted. This line right here is the median. For the altitude also known as the height of a triangle, the height of a triangle always hits at a right angle. So that's really important to know as well. Now, perpendicular bisector kind of is both of these things together. This line right here is the perpendicular bisector. It comes down, and first it's perpendicular. Second, it's a bisector, and it's a really powerful bisector. It not only cuts the opposite side in half, it also cuts this angle in half. Now, what I'd like you to do is fill in these missing words in the definition, and then I'd like you to create your own definition here. Now I'm going to be asking you, what is a perpendicular bisector? And you might say that it joins the vertex to the opposite side, but I'd like you to list 3 things that a perpendicular bisector does. Now we're in kind of the middle section of your notes, and I'd like you to write the title, The Almighty Perpendicular Bisector. This section is all about perpendicular bisectors only. So the first thing you can do is fill in theorem 4-5, 4-6, 4-7, and 4-8. Those are just for reference really. And then what I'd like you to do is to think about the diagram that's given in these 4 theorems. What I did is I drew the diagram but took out the hypothesis and conclusion for each of these theorems. The first thing we're going to do is look at just the hypotheses. And the hypotheses you can figure out by looking at what's given. So I'll do the first one for you, and then you can do the bottom 3. So here's what I notice. I'm given a point, and that point is on a line that is both perpendicular and it cuts that segment in half. So I'm given a point that's on a perpendicular bisector. Let's find that. A point that lies on a perpendicular bisector. What I'd like you to do now is pause the video and try to see if you can match the 3 hypotheses here to the 3 pictures that you have here. Then unpause and see how you did. Alright, go ahead and pause. Okay, for the second theorem, I notice that I'm given a point, and that point is the same distance from this side as from this side. It's an equal distance. It's equidistant from the sides of a segment. So I would say that it is a point that is equidistant from the endpoints of a segment. For the next one, I'm given a point, and that point's on a line that cuts an angle in half. So the point is on an angle bisector. That would be this one. And last but not least, well, it's pretty obvious. It's got to be this one, but let's see why. This point is the same distance away from these 2 segments, which also happen to be the sides of an angle. That's why it's a point that is equidistant from the sides of an angle. Now that we filled in the hypotheses, we're going to think about what these hypotheses do and what they mean to the picture that's given here. We may have noticed that the hypotheses has a diagram, and the same diagram is under the conclusion. What I'd like you to do is to take a marker or a different colored pen, and we're going to actually draw in what the conclusion is first. So what this conclusion says is that if a point on a line, is on a line that is a perpendicular bisector, then that point, if you connect it to the endpoints of a segment, it's the same distance from the segment on both sides. So there's that one. For your second theorem, it says that if you have a point that is equidistant from the segment, then there exists a perpendicular bisector, and it may not be seen, so I'm going to draw it in. There exists a perpendicular bisector. What I hope you're noticing is that these two theorems are related. In fact, they are converses of one another. So go ahead and write that in, that these two are converses. I don't know if I can get that to fit. Let's see, converses of each other. Now, I'd like you to go ahead and pause the video and put in the two conclusions based on what we drew in. So we drew in two segments that were the same distance away from the endpoints, and we drew in a perpendicular bisector. Go ahead and pause the video and see if you can find those conclusions. Alright, so you should have paused the video. Let's see how you did. The point is equidistant from the line. I just fixed the typing on it. So then the point is equidistant from the line, and thereby the point lies on a perpendicular bisector. I'm going to move that. Let me make this a little bit smaller. There we go. So what I hope you notice is that these two theorems are related and that they are converses of each other, and that you notice that there is some equality coming on, some congruencies you can find if you're given one of these two scenarios. Now let's look and see what happens with these two angles right here. So in this case I have a line that's on the angle bisector, and over here I have a line that's equidistant. I think you know what's going to happen here. If you have a point that's on an angle bisector, then that point is equidistant from the sides of the angle. And if you have a point that's equidistant from the sides of an angle, then that point is on an angle bisector. I'll go ahead and draw on those two parts. And again, let's note that these two theorems are converses of each other also. Converses of each other. So if you remember one, you should be able to remember the other. You can pause the video and put in the conclusions for this one, then unpause when you're ready. Alright, let's check and see. Then the point is on the angle bisector. Then the point, let me make this a little bit smaller. Then the point is equidistant from the endpoints of the segment. Now these are all four important things that happen that are related to perpendicular bisectors and just points on angle bisectors. And please think about those and keep them in mind when you're dissecting angles and sides of problems. In the last 5 lines of your notes, I'd like you to copy this question, the Who Am I game, where your answer is either it's a median, altitude, or perpendicular bisector. I'm going to reveal 4 different pictures, which I'd like you to copy down, and then I'd like you to name what they are. Let me show you the 4 different problems. There's this triangle. We'll call this question 1. I'd like to know what's AD. There's question 2. Here I'd like to know what's BC. There's question 3. Here I'd like to know what's BC. And last but not least, question 4, I'd like to know what is segment AD. Go ahead and pause the video and write down next to each one, after you copy the diagram, what each of these is. Go ahead and pause the video and unpause when you're ready. Okay, if you unpaused it, you better have 4 answers in these 4 slots. I know some of you cheat. Did you write them down? Pause it. Okay, I think you're done now. Alright, in number 1, I noticed that AD makes a right angle, but it doesn't say that BD is congruent to DC. That means it's an altitude. Number 2, I noticed that BC makes a right angle, doesn't cut the bottom section in half, so it's also an altitude. So question 1 and 2 are both examples of what a triangle's height looks like. Number 3, BC makes a right angle, and it cuts this bottom opposite side in half. That means that BC is an altitude, but more specifically, a perpendicular bisector. That means that BC is also the height of the triangle, but it's a special height because it also cuts this bottom opposite side in half. Last but not least, AD does not make a right angle, but it does cut the opposite side in half, so it is a median. All right, good luck and be prepared to play the Who Am I game again.